Welcome back. In the previous video, we learned about digital pins used as outputs controlling LEDs. Today, we'll expand on that by covering digital pins as input, as well as diving into analog pins and PWM pins. So let's get started. Let's start with a quick recap of digital pins as input. Digital pins not only work as outputs, but also as inputs. When set to input mode, they can read the state of a switch or button, detecting whether it's pressed or not. Here, I've connected a simple button to digital pin 2. In the code, we use pin mode to input, so the second pin as an input. And with digital read pin 2, we can check whether the button is pressed or not. So, is it high or is it low? In addition, if you don't know how to use buttons with Arduino, you can check this video on my channel. As you can see, when the button is pressed, the value changes to high, and when it's released, it goes back to low. This concept is not complicated as it is important, because in complicated projects you will use too much digital pins as inputs for remote control, for controlling something with buttons or something else like that. Now let's move on to analog pins. Unlike digital pins that only read high or low, analog pins can read varying voltage levels, which is perfect for sensors that provide continuous variable data. So we use analog pins primarily for reading analog signals from the other components, especially from the sensors. For example, here I connect a potentiometer to analog pin A0. As I turn the potentiometer, it changes the voltage value that the Arduino reads. This is done using the analog read A0 function. The values you see in the serial monitor range from 0 to 1023. This range corresponds to the voltage between 0 and 5 volts, allowing you to measure a variety of sensors with precision. While analog pins are primarily used for reading analog signals, they can also be used for outputs, particularly for generating PWM signals. This is useful for controlling things like motor speed, LED brightness, and other devices that require variable power. To use an analog pin as output, you just need to configure it with pin mode, the analog pin as output in your setup function, like with any digital pin. Then in a loop function, you just write analog write the analog pin and a number between the range of 0 to 1023. Next up, we have PWM pins. On Arduino, the PWM pins are marked with a symbol, one of the most versatile features of the Arduino. As mentioned, PWM stands for Pulse Width Modulation. But what does it mean in practice? Think of PWM as a way to stimulate an analog signal using digital technology. While Arduino can't generate true analog voltages, it can switch a digital pin on and off very rapidly to create an average voltage over time that mimics an analog signal. The frequency of this switching is constant, but we can adjust the duty cycle, so the proportion of time the signal spends being high versus low. For example, a 50% duty cycle means the pin is high for half the time and low for the other half, giving us an average output of about 2.5 volts on a 5-volt system. By changing the duty cycle, we control how long the signal stays high compared to how long it stays low. The higher the duty cycle, the closer the average voltage is to 5 volts, and the lower the duty cycle, the closer is to 0 volts. Here I connect an LED to PWM pin 9. Now, by using the analog write pin 9 and the value between a range of 0 to 255. So what does it mean? Setting the value to 0 will turn the LED off, while setting it to 255 gives the LED full brightness. And value in between controls the brightness smoothly. PWM pins are not limited to controlling LEDs. They are especially for controlling the speed of motors. But you can't connect a motor directly to Arduino. You have to use a motor driver like L298N motor driver. But it's another video's topic. It's important to keep in mind that PWM pins aren't truly analog. They are digital signals that simulate an analog output. So if you need to generate a real continuous analog signal, you would need something like a digital to analog converter, or using the analog pins of Arduino. So this is all about the Arduino pins, guys. I hope you liked this video and also the previous video, which was the first part. Thanks for watching and see you in the next video.